Part A has two parts. The first is to calculate the Pearson's product moment correlation coefficient R for this data here in this table. And the second part is to therefore comment on the result. So in this question, we have a pizza restaurant, and we are interested in the amount of money that the pizza restaurant brings in, which we call revenue, depending on the number of guests. And as you would kind of think, that the more guests that come in, the more revenue that would come in. More people are buying more pizzas. So it's pretty clear that as the number of guests increases, the amount of revenue the store brings in increases. But what this question is really asking for is there a direct relationship between the two? And that's what we're sort of finding here with the correlation coefficient. So I'm going to use my calculator to find this R values. Let's go ahead and do that. Let's go out of there and let's go into the green statistics section. And I'm going to label my two columns here. The first one is X for number of guests, and the second column is Y for the amount of revenue. And let's type in this data here. I'll type the first few and then I'll pause the video. So it'll be 45, and then 54, 39, and now I'm going to pause it and enter the rest of the data in. Okay, so that's the bottom of the first column, which corresponds to the number of guests row in our table. Tab across to the next column, back up to the top, and we enter the revenue data in now. So 410, and again, I'm going to pause the video and complete this. Okay, so there we have our data there. I'm now going to go to the next available column, go back up to the top. Now I'm going to perform a stat calculation. So we go menu, number 4, statistics, number 1, stat calculation. And I'm going to choose this number 3 here, linear regression mx plus b. It's going to give me some good information here, not only about the correlation coefficient, but also about the gradient and the slope, which will be useful for later parts. So part B, part B pretty much. So click this one here. Now my X list is my independent variable, which is the X column, number of guests. My Y list is my Y column. That's all I need to enter here. Hit OK, and there we have it. So the information that we need for part A is this R value here, 0.991 to 3 significant figures, which is what you can see there. So that's the answer to the first part of A. And the second part is to then comment on the results. So let's just do a crash course in R values for correlation coefficient. So we have an R value here. Now R values are all the way between 1 and -1, and 0 in between. Now, as we go from 0 to +1, the correlation gets stronger in a positive correlation. So not only does it get stronger, it also, because it's a positive number, it indicates that the correlation is positive, which means that if I was to draw a scatter diagram here, the data points will look like this. It's positive because as one variable increases, the other variable also increases. It slopes upwards. Conversely, if the R value was negative, closer to -1, this is actually negative correlation, which means our scatter diagram will look like this, which means that as one variable increases, the other variable actually decreases like this. But also, if it was -1, it would also be very strong. It would just be a strong negative correlation. So the two words that you need to determine is its sign or direction, whether it's positive or negative. So in this case here, it is a positive number, so it's a positive correlation, and also how strong it is. And usually about 0.85 and above will be strong. About 0.5 to 0.85 is moderate, and below 0.5 is weak. There are, depending on which textbook you read, there might be slight modifications to that, but sort of generally in that area, you're sort of on the right path here. So because this is quite high, 0.99 is actually very strong, I would classify this as positive, strong correlation between the number of guests and revenue. Part B asks to write down the equation of the regression line y on x. So the regression line will always be in the form y equals mx plus c, where my m is my gradient and my c is my y-intercept. And the y and the x refer to the variables, which in this case here is y will be the revenue and the x will be the number of guests. Now, we have done the hard work for this part back in part A. So if you're not sure how I got this screen here, this stat calculation, I recommend going back and watching part A. But now I have my M value is 10.4. So in my regression line equation, my M value is 10.4, which you can see here. And my C value, which is the B value in the calculator. The calculator uses MX plus B, same thing, it's just the constant at the end, is negative 14.3 to three significant figures. So you can see here my C value, my constant is negative 14.3. So there we have it, equation of regression line y on x. Part C asks to use the line of regression equation, which is this equation here we found in part B, to estimate the revenue of serving 70 guests and to give our answer correct to the nearest dollar. So just before we go into our working here, let's just have a look at the table. 70 guests occurs about here. So between, actually this isn't in ascending order, but roughly if we were to sort of halve between 51 and 89 guests, and if the correlation was strong, which it is, we determined that in part A, we would assume that the revenue is going to be about halfway between 558 and 906. So we would expect our revenue to be about sort of 700 to 750, I would think. But let's go ahead and use our line of regression equation to actually estimate what the revenue will be on 70 guests. So we have this equation here, y equals 10.4x subtract 14.3. The y stands for the revenue, the x stands for the number of guests. So we're now going to actually substitute in x equals 70 because we want to know the equivalent revenue for 70 guests. So I've just taken this equation down, substituted in x equals 70, used my calculator, and I get 713.7. So rounded to the nearest Australian dollar will be 714 Australian dollars. Part D, determine if the restaurant makes a profit when serving 45 guests on a particular day. Now, just before we talk about the cost part of this, we actually do have a data point already up here, this very first data point, which is the revenue for 45 guests, which is 410. So we actually don't need to use our line of regression equation this time because we actually have a data point exactly what we're after. The costs is a daily cost for the restaurant. That might be the electricity, the water, etc., the management of 240 Australian dollars, plus the variable cost of serving one guest is $5, which might be the actual raw ingredients of the pizza itself, the associated waitering costs for that people. So this is the variable cost. We have a fixed cost of 240 and a variable cost of $5. So profit is equal to revenue, so the money that's brought in, subtract the cost, the money that goes out. The revenue we can read off the table to be 410. The cost, and you can see I've put this in a bracket here, is the fixed cost of 240 plus 45, the number of people, times the variable cost, 5 times 45. So if we perform this calculation, we get negative 55, which doesn't sound good. That sounds like a loss, not a profit. Hence, the restaurant makes a loss when serving only 45 guests. So this is very common for actually all types of businesses, really, whereby you have a lot of fixed costs and you need to serve a certain number of customers in order for whatever the business is, a restaurant or a software company, maybe. You have a certain number of customers such that it actually turns profitable. Someone could be making desks and the first desk actually doesn't cover the cost of the sort of warehouse to make it. So in this case here, 45 is not enough people. They need to be serving more people to turn a profit. And we're going to get into that in part E. Part E has 3 parts, so let's work through them one by one. The first is to write down an expression for the total revenue of serving X guests. Now, this is a pretty simple one, this one, because this actually is the same as our line of regression equation. So if I go back up to part B, we determined a line of regression equation. We called it Y at this point in time because it was Y on X, but Y is actually the revenue. So the revenue, I can replace the Y with maybe a capital R or even a lowercase r, standing for revenue, is equal to 10.4 multiplied by the number of guests, and we're calling number of guests X. We could potentially replace that with G for number of guests, but we'll keep it as X, subtract 14.3. So back to my working here, the revenue is 10.4x, subtract 14.3. Let's now move on to the second part of E. Find an expression for the profit now of the restaurant when serving X guests on a particular day. So let's start with the very basic equation that profit is equal to the revenue, the money that the shop brings in, subtract the cost, the money that the shop sends out for costs. Now the revenue expression is 10.4x subtract 14.3. We just determined that in the first part of E. And the costs will be, we talked about this in part D, our fixed cost of 240 plus our variable cost, which is 5 times the number of guests. To go now from the second line to the third line, I just group like terms. Actually, this line to this line, all I've done there is just remove the brackets. And to go from the third line to the fourth line, I just group like terms. So my x's I can group together, 10.4x subtract 5x, and my constants I can also group together, negative 14.3 and negative 240. So this is what I get here, which is a really useful equation now. This is an equation for the profit on the restaurant for a particular number of guests, which then leads nicely into part 3 of E. We are asked to find the least number of guests required to be served to result in a profit for the day. Okay, so let's have a look at this. Before I get into E, I just want to talk about this equation here, the profit equation. If I didn't have any guests, let's say, it would be 5.4 times 0, no guests, subtract a fixed component of 254.3. So the restaurant would actually lose $254.3 that day. However, for every additional customer, the loss becomes sort of less and less, which eventually reaches 0, and then every additional guest will become profitable. So the question is, well, how many customers is it in order for the profit to equalize at 0 before it becomes sort of more profitable? So to find this out, we're going to use this profit equation and let it equal 0. We need to find out when the profit is 0 and then solve for X. So that's what I have done here. I have then used numerical solve to solve for X. Let's go ahead and do that. So I'm going to solve this first line here. So menu, algebra, numerical solve. It will be 2.4x subtract 254.3 equals 0, and then I need to tell the calculator what to solve for. So I go comma x, hit enter, and I get, what's happened there? Sorry, I made a mistake on the so I'll just fix that mistake up. I go up, hit enter. That's actually not 2.4, sorry, that's 5.4. Hit enter, and then I get 47.09. So rounded to 3 significant figures, that'll be 47.1. Now, of course, I can't have 47.1 customers. People are only wholes, they're whole humans. So it's either going to be 47 or 48 customers. Now, 47 will result in a number that's just slightly negative. So the restaurant still actually makes a loss on 47 customers. So the first profitable customer will be the 48th customer. So hence, at least 48 guests are required to be served for the restaurant to make a profit.